Hey guys, welcome to the fourth lesson of our linear unit. In today's lesson, we're going to get into chapter 1F, graphing straight lines. Okay, graphing your straight lines. Now, just a quick recap. Last lesson, you would have learned about in 1D solving linear equations. So, understanding this and also the previous stuff on chapter 1B and 1A is going to help you really get a good grasp of what it means, okay, to draw a linear equation and graphing linear lines, okay, because a lot of the stuff will involve algebra and will require you doing a bit of rearranging, understanding how to get unknown variables, okay, and basically all the algebraic stuff that you would have learned in the previous lessons is going to now apply to this part. So let's get started. So as a starter, here's a example that we're going to go through together and try to understand how linear works. Okay, so here are 5 equations, sorry. So keyword there is equations. Remember your equation, so your criteria for an equation needs to have an equal sign, okay, and no square roots or no indices or powers. Okay, so here are 5 equations and 5 graphs. Match each equation with its graph and give a reason for your choices. All right, so let's match, okay, some of these equations on the left, so these equations, with the lines that are here on the right. So I'll start with the first one, y equals -3. Okay, y equals -3. Now, if you look at our graph here, okay, this is a Cartesian plane. So just a quick recap, a Cartesian plane, okay, has 2 axes or axes. You've got x. The x-axis is the horizontal, so left to right, and your y-axis up here is your vertical, top to bottom. Okay, and you can see that how the numbers work over here on the x-axis on the right hand side, okay, is where you've got all your positive numbers, and on your left hand side is all the negative numbers. For your y-axis, all the positive numbers are up top and the negative numbers are on the bottom. And over here in the middle is what you call the origin, where everything sort of starts. So that's kind of like your reference point as to know where your positive and negatives are. So if there's your origin here, anything on the right and on the top is positive, and anything on the left and on the bottom is considered as a negative. Okay, so for the first equation that we went through there, it's we're looking at y equals -3. Well, what that's saying is, let's look for, or what we should look for in that case is, on our y-axis, is there any line or any of these colored lines crossing through -3? Well, let's find -3. And I can see that -3 is down here on the bottom. Okay, so therefore, my line for y equals -3 is the red line right here. Okay, so this red line is y equals -3. Okay, and you can see the properties for that. Y equals -3. It's just a straight line that crosses through y. Okay, just a straight line that crosses horizontally through y. Okay, that -3. So that's what y equals -3 would look like. So if I had y equals 2, then you'd have a horizontal line that goes through the number 2 up there. Okay, let's try another one. X equals -2. Okay, so let's look for x equals -2. Now again, x-axis is this horizontal line here. So if all my positive numbers are here, where are my negative numbers? Well, they must be on the left somewhere. And is there any line that crosses through -2? Yes, there is, right there. Okay, this vertical line here. Okay, so right here, this line represents x equals -2. Okay, that vertical line represents x equals -2 because it passes through the -2 line on the x-axis. Okay, and it crosses through there. And so now you can see that's what x was going to look like. So if you get an equation that looks like this x equals -2, it's going to be a vertical line that goes through the x-axis. If it was x equals 3, then it'll be over here somewhere. Okay, let's do the next one. Y equals 1/2x. Ooh, tricky. Okay, 1/2 x. Okay, now I'm going to just give you the answer here, but in terms of reasoning, it'll make more sense later on when you watch the next few sections of this video. Okay, but y equals 1 over 2x, okay, is actually this blue line here. Y equals 1 over 2x is this light blue line, sorry. So let's write that down here. So just 1 over 2x. Is it 1? Yeah. Doesn't matter where you put the x really, but I'll just leave the x. I'll put it on the side. Let's make it nice and easy to look at. So now you might be wondering, why is that the case? Okay. Now for this question to make sense, okay, this equation tells me just the gradient. Okay, this here is just a gradient, 1 over 2x. And there is no other number here to signify what we call the y-intercept. Okay, so in this case, the gradient, okay, is coupled together with this variable x. And if there's no other number next to it, or like a +3 or a +4 or -2, which signifies the y-intercept, and the y-intercept refers to where this line hits that y-axis. So in this case, because there is no y-intercept, the y-intercept is actually 0. So it hits it right there at the origin. Okay, and hence why that is the line, or that is the rule. Okay, this one for this line here. Okay. Now there could be other reasons as well, but I'm going to stick with those for now, just so that it's easier to understand for you guys. Next one is y equals -3x plus 3. So I'm just going to stick to the intercept stuff. So for this one, okay, y equals -3x plus 3. Remember I mentioned that this is your gradient, and the number that is by itself, which is the coefficient, I mean the constant, sorry, the number by itself is the y-intercept. So if you look at that +3, are there any lines here in this form graph that crosses the +3 of the y-axis? So if there's -3, can't be that one. Has to be this one, +3. Okay, so this purple line, okay, actually represents that equation of y equals -3x plus 3. Other things to help you understand why that's the case as well. See my gradient, -3x. Your lines, okay, actually have two different properties of whether they're positive or negative. So if you look at a line and it's going upwards, it is actually positive. So for example, this blue one, light blue, okay, that has a positive gradient. 1 over 2 is a positive number, so it's going to go upwards. This purple line, okay, y equals -3x plus 3, has a negative gradient, and we can see -3x, -3 is a negative number, therefore it's going to go downwards because the gradient is negative. Okay, so if a line is positive, okay, the gradient is a positive. So if a line is going upwards, sorry, the gradient is a positive number. If a line is going downwards, the gradient, so that number that is coupled with the x, is going to be a negative number. All right. And the last one is 3x minus 2y equals 6. Okay, now that one is slightly tricky. Okay, but we can you can assume that the green one is going to be 3x minus, what was it again? 3x minus 2y equals 6. So 3x minus 2y equals 6. Now this one's slightly trickier because the equation does look jumbled up. But the reason why, apart from, you know, trial and error, sorry, process of elimination, that is the last equation, is you have to look at the intercepts. Okay, you got to look at the intercepts and where they're at. Now, in terms of finding the intercepts, you can't just say that, oh, yep, y-intercept is 2 or -2 and the x-intercept is 3 because they're coupled together. Okay, don't do that, please. Okay, in order to find the intercepts, you need to change some of these variables into 0. Okay, so I will go over more of that later on, but basically what this looks like is, if you want to find out what the x-intercept is, you have to change y to 0. So in your formula for x-intercept, okay, it's going to be 3x minus, change the y to 0, equals 6. And then you solve for x. Figure out what x is there. Okay, oops, sorry. Let's fix that up. So solve for x. So basically you're left with 3x. Negative 2 times 0, well, it leaves you with nothing, so 0 equals 6. And we solve for x. So if you look back at our previous lessons, you'll know how to do this. 6 divided by 3 equals 2, so the x-intercept is 2. And if you look at the line there, you can see that it hits the number 2 on the x-axis. So if you wanted to find the y-intercept, let's use a different color. So the y-intercept, so that's going to be 3x. So if you want to find a y-intercept, change x to 0 here. So 3 times 0 minus 2y equals 6. Okay, and then now we solve for y. So 3 times 0 will leave you with nothing, so you're left with 2y equals 6. Okay, and then from there, solve for y. So this negative 2 is a time, so when you get rid of it here, it becomes a divide by negative 2. So y equals negative 3. So the y-intercept is negative 3, and that makes sense. You can see that the green line, okay, hits the negative 3 on the y-axis there. Okay, so hopefully that's given you a good sort of understanding of how the lines and these equations actually relate to one another. Okay, Alright, so let's continue on with the rest of this. So just a couple of things that I mentioned here, okay, are going to actually be covered now in over here, this section here. Okay, so hopefully all this information will make a bit more sense now that we're actually going to talk about it and not just look at the examples. So here, gradient. Okay, the gradient, you might have seen this in your previous years with the gradient m. So you normally you'll see the gradient in an equation represented with the letter m. Okay, oops, sorry. Okay, so the gradient is represented with this letter m. Okay, it's a number that describes the slope. So whenever you see gradient, same thing as slope. Okay, gradient and slope are actually the same thing. Okay, m, slope, gradient, same thing. Okay, and it describes, okay, how slopey a line is. So the greater the gradient, okay, but generally the higher, the more slanted the line becomes. Okay, but slanted in a sort of this kind of fashion. Okay, hopefully that makes sense. But this kind of way, if a gradient is a less or a lower gradient, it becomes a little bit more flat. Okay, so the higher the gradient, the greater the slant, I guess you could call it that. The smaller or the lower the gradient, the more flat it becomes. Okay, the gradient also can be described using this little equation here called the rise over run. Okay, so the rise over the run, okay, basically just measures, okay, from 2 points on a graph, what is the rise and what is the run. So if let's say you have a point here and a point over here on this graph, what is the amount that it rises by and what is the amount that it runs by. Okay, and we'll get into more of that a little bit later on. Okay, so but that's what the gradient describes. The gradient is the change in y per 1 unit change in x. Okay, so one way I could try and explain this is basically the gradient just tells you how much you go up by each time. Okay, how much you go up by each time you have one of these x's. So if you have 1x, so if you go up by 1x, or if you do something for 1 day, okay, the y would increase by this amount. If you go up by 2 days, y would increase by this amount. Okay, so the gradient just tells you how much do you increase or decrease by for every unit of x that you have. So every time you go up by an x or by a number, how much does the rate of change of y become? So I think one example, one way that I could better explain this would be through an equation. Okay, let's say you have y equals 2x plus 3. Okay, now in this equation, the gradient is 2. Okay, so that means that every time you go up by 1, it's going up by 2. Now, think back to the previous topic that we learnt about with recursion. This too is more or less the same as a common difference. Okay, it's very similar to a common difference. How much does it go up or down by each time? So every time you add a day or you add the next term, how much have you gone up or down by? Now in this case, this is saying that we're going up by 2 each time. So if I change x to 1, or the first term if you want to call it that, plus 3, okay, you're left with y equals 2 plus 1 is 2 times 1 is 2 plus 3, therefore y equals 5. So the first term, for in this case is 5. What about if I go up by 2? So that means if it's 2 this time, so if I change x to 2, what's the next amount going to be? So remember, this gradient just tells you how much you're going up by each time. So you're left with 2 times 2. So I'm going to look for the next one, plus 3. So y equals 2 by 2 is 4 plus 3. And we know that the common difference, how much it goes up by each time, is 2. So you can presume that if you go up by 2 again from 5, 4 plus 3, y equals 7. Okay, so that's what the gradient is. Basically just tells you how much you're going up or down by, depending on the value of x. Okay, let's move on. Intercepts. Okay, so every graph where there are lines drawn in there is going to have an intercept. Okay, think of an intercept as where the actual line of the rule of the line actually hits the x-axis or the y-axis. Okay, so in this case, intercepts are the points where the line crosses x and y. The y-intercept is the value of y where x is 0. So what that's saying is the y-intercept. So if you look at this graph here, let's look at the red line for now. Okay, this y-intercept, okay, here, okay, the value of the y-intercept, okay, over here is whatever that negative value is. But if you think about the coordinate for this, okay, the actual coordinate is the x is going to be 0 and y could be like negative 4. So what this statement here is saying, the y-intercept is the value of y where x is 0. Okay, what is the point of, what is this coordinate here, okay, if x was 0? That's what that's saying. So this is the value of this when x is 0. So when x, this line is on this point here, 0, what is this point? Okay, you can also think of that as the starting term. So to relate this back to recursion, okay, it's the starting term in this case. All right. And the other point there is the x-intercept is where the x-intercept is the value of x when y equals 0. So just think of it as where the line hits the x-intercept. And in that case, you can see that y is 0. So you haven't gone up or down anything. You're just at 0 here. But for x, you have moved here negative 3 or whatever the negative number is here. Okay, so those two statements, hopefully that makes sense. So the y-intercept is the y value where x equals 0. And the x-intercept is the x value when y equals 0. And that, if you look back at this part of the video where I was using the intercepts to justify the rule for this line, this green one, okay, you can see that I actually changed the x and the y to 0 depending on what I was looking for. So if I'm looking for x-intercept, I change y to 0. If I'm looking for y-intercept, I change x to 0. Okay, so that's where that comes in handy. Let's keep going. The gradient of a line can be positive or negative, as I mentioned before. So positive, if it's going upwards, so like this. Choose another color. Positive if it's going upwards. Oops. So like so. And then negative if it's going downwards. Okay, like so. And 0 would mean that the line is actually just horizontal like this, straight. Okay, just a straight line like so. That's a 0 negative. Undefined, okay, is vertical. Okay, so when the line just goes up or down, like so. Okay, that's an undefined gradient. The gradient intercept form of a straight line is y equals mx plus c. I don't think I've mentioned this earlier, but this is the basic rule for any formula. Y equals mx plus c. And we know that m, remember if you look back a few minutes earlier, m is the gradient. Okay, that's the gradient. And c represents the, and I did mention this before, c represents your y-intercept. So it's generally a number that is by itself. So the c is the y-intercept. We'll get into this a little bit more later. But m is the gradient, c is the y-intercept. Okay, let's move on. 2 points are generally needed to draw most graphs. Okay, so whenever you draw a graph, you actually need to have 2 points. Okay, and we'll get into more of understanding how to get 2 points. And special lines include those with only one axis intercept. So what that's saying is, and I did mention this before here. So if you look at the red line, this red line, and this blue line, and this light blue line, they are special. Because if you look at the formulas for them, okay, x equals -2, and then you've got y equals -3, and the last one up here, y equals -1/2x. You can see that they're all just numbers with no y-intercepts, or with no constants. Okay, because they actually only have one intercept only. They only intercept the axis once. Okay, there's no gradient. Oh, there's no. There is gradient, especially for this one, but these two don't. Okay, and they're considered special lines because they just cross through the axis once. Okay, and let's see. Special lines include those only one axis intercept. So horizontal lines. So when you see a horizontal line, so when you're asked to draw a y equals, so let's say for example, y equals. In this case, I don't know, let's call this 2. Okay, y equals 2, then this line would represent y equals 2 because it goes through the y-axis at +2. If you're being asked to do, let's say y equals, let's try another one, y equals -2. Okay, in that case, -2 would be like over here. So the line would look like this. Okay. Let's say for x. All right, what about x? X equals, let's do x equals 1, for example. In this case, I've got an x line here, but x equals 1. So let's say that that's 1, that's 2, that's 3. X equals 1 would look like this. Okay, because it's just going through the x-axis. And the other one that's there is y equals mx. Sorry, let's just fix this up. Y equals mx. Okay, this one here. Let's say that the gradient was like 3. Let's go 4x, for example. Okay, there is no y-intercept, so you can start here, right in the middle. But then you'd have to figure out what is the rise over run. Okay, so in this case, let's say that this is 1, 2, 3, 4. Just making up some random numbers here, guys. This does look a bit confusing, but it'll make a lot more sense when we actually do the work. Okay, we'll do some more examples later. What was I doing? Okay, so let's say that this is 4/1. Okay, that's my gradient. That means the rise is 4, the run is 1. So that 1, 2, 3, 4. The rise is 4 and the run is 1. There's my other point, and then from there, okay, I can draw my line. Okay, let's move on to the next part and actually do some of these examples so we can actually get what we're doing. Alright, so this part here, decide if the point -2, 7 is on the line within the given equation. So with a question like this, okay, all you have to do is substitute these points into this the equation. Now remember, for any coordinate, okay, when you get a coordinate like this, the first number is x, the second number is y. That's any coordinate. Now all coordinates you're going to get this year are just 2 points, or two numbers. So the first number is x, the second number is y. So there's your coordinate, -2, 7. Substitute that into this formula. And what we're going to do is, by substituting it, does the formula actually make sense? If it doesn't make sense, then it's not, this point is not in the line. If it does make sense, then this point is in the line. Okay, so let's say now we substitute y with 7, -3 times, and x is -2 plus 1. Okay, so let's solve that. -7 equals -3 times -2. Remember, BODMAS, do the brackets first. -3 times -2 gives you +6 plus 1. Solving that, 6 plus 1 equals 7. 7 equals 7, which is true. So that means, yes, this is -2, 7 is within the point, with this point here is within this line. So it makes sense. That's correct. Let's try this one. So 2x plus 2y minus 1. So 2 times -2. Remember, x was -2 plus 2 times 7. 7 equals 1. Remember, do the ones in the bracket first, please. So BODMAS, 2 times -2 is -4. Plus 2 times 7 is 14 equals 1. I can already tell that this is not going to be right because 10 does not equal 1. Therefore, this point does not fall within, okay, this equation. Okay, as in this -2, 7 does not fall in line with the line drawn for this rule here.